morning to everyone. My name is Elena GAUDENZI. I'm a PhD student from Politecnica University of Marche, and the title of my presentation is Biobinders for Sustainable Asphalt Mixtures. My tutor is Professor Francesco Canestrari, and my research project is co-financed by the Swedish petrochemical company Ninas. The presentation is structured as follows. Objective of the project: description of the first material investigated, a binder and asphalt mixture containing bio-oil with its respective methods and results, as well as a binder and asphalt mixture containing aircraft lignin, overall conclusions and publications. The objective of this project is the evaluation of the effects induced by the use of renewable sources on the performances of bituminous materials from a chemical, rheological and mechanical point of view. Both biobinders are obtained by replacing part of bitumen with different renewable sources derived from byproducts of wood pulp and paper industry, in the specific a bio-oil and a craft lignin, thus promoting sustainability and circular economy principles. A wood bio-oil, coded as A, was dosed at 10% by weight to replace a conventional 50-70 penetration grade bitumen. Some characteristics of the bio-oil are listed in the table below, such as the kinematic viscosity and the hydrocarbon composition that makes it compatible with bitumen. The blend was obtained in laboratory through the use of a high shear stirring mixer, setting the speed, the temperature and the timing. From previous studies and in accordance with what found in literature, it emerged that the bio-oil addition causes a consistency reduction. For this reason, a plain bitumen characterized by a similar consistency, 115 penetration grade, was selected as reference material. The same binders were also used for the production of asphalt mixture for wearing cores, characterized by the same design gradation and binder content equal to 5.8%. Thus, rheological tests, test frequency and time sweep, were run in order to obtain master curves and to compare the fatigue response of both binders. Then, a conventional mechanical investigation consisting in indirect tensile stiffness modulus, indirect tensile fatigue test, and semicircular bending test was performed on asphalt mixtures. Both unaged and long-term aged conditions were investigated. From frequency sweep tests, master curves were obtained at the reference temperature of 34 Celsius degrees. The results show that the biobinder and the 115 penetration grade bitumen are perfectly comparable to each other in the entire frequency domain, showing a similar complex modulus trend in both aging conditions. Then, time sweep tests were performed to investigate the fatigue behavior of asphalt binders. They consist in applying a cyclic load at a selected frequency in control temperature and control strain, selecting a strain level higher than the linear viscoelasticity limit, thus entering in the nonlinear domain. The decrease of the loss modulus was selected as failure criteria. Results show again perfectly comparable performances both in unaged and aged conditions. From the ITSM test, the bio-oil-based asphalt mixture shows perfectly comparable stiffness properties with the reference one, denoting a comparable thermal and aging susceptibility. As far as fatigue resistance is considered, no substantial differences emerge in unaged conditions. Differently, a slightly reduced performance is attributable to long-term aging, which shows a higher slope of the fatigue envelope and a reduced epsilon 6 value. Finally, from the cracking analysis, the bio-oil-based asphalt mixture showed higher fracture toughness in unaged conditions, but the higher resistance is not confirmed after aging. In contrast to the bio-oil, which was in liquid form, a powder craft lignin, coded as S, was selected to replace part of bitumen and obtain a biobinder. Specifically, a 70-100 penetration grade bitumen was partially replaced with 30% by weight of lignin. The lignin content was optimized to obtain a biobinder characterized by a 50-70 penetration grade consistency, that is the most employed at Italian latitudes. For this reason, a 50-70 plain bitumen was selected as reference material. Even in this case, a high shear stirring mixer was used to produce the biobinder in laboratory. Then the same binders were employed to produce asphalt mixture for binder cores. Both mixtures were characterized by the same aggregate gradation, including 15% of rough, while the binder content was optimized based on volumetric considerations. In the end, the use of the biobinder resulted in a 15% reduction of bitumen in the mixture. A similar approach, consisting in frequency sweep and solubility test, was adopted for the rheological and chemical characterization of bituminous binders, as well as the same conventional mechanical characterization was reproduced on asphalt mixtures. Moreover, a more advanced mechanical characterization of asphalt mixtures, consisting in the viscoelastic continuum damage theory, was also performed, consisting in master curves and fatigue tests. This approach differs from the conventional one in that the theory on which it is based allows the direct determination of the intrinsic properties of the material, which are not related to the specific test conditions imposed, and this can reduce the number of the test repetitions. In addition, the use of reduced geometry allows for a significant conditioning and testing time saving. From frequency sweep results, it is possible to see that lignin causes a significant change from a rheological point of view. First, an increase of stiffness is registered in the entire frequency domain, despite both binders were characterized by the same penetration rate, but the difference in stiffness is reduced after aging, which means that the biobinder seems to be less affected by aging. Moreover, a horizontal asymptote that is typical of modified bitumens or mastics appeared in the low frequency region, and it could mean that part of lignin probably acts as a filler. At the same time, solubility test highlights a reduction in the soluble matter after aging, which could mean that part of lignin generates chemical bond with bitumen becoming part of it. Passing to the asphalt mixtures, from the ITSM test, the lignin-based one confirms the higher stiffness experienced at binder level at all the investigated temperatures. At the same time, the lower thermal and aging susceptibility is also confirmed. A slight reduction in fatigue life appears in unaged conditions, even if perfectly comparable performances emerged in aged conditions, as shown by the epsilon 6 parameter. From the cracking analysis, the lignin-based asphalt mixture seems to improve the aged performances, despite a lower resistance is experienced in unaged conditions. The same findings in terms of stiffness and aging susceptibility are also confirmed by the master curves obtained by applying the VCD model, while fatigue cracking potential is described by a specific index which confirms a reduction of the lignin-based asphalt mixtures in unaged conditions, even if a slight reduction is also found after aging, and this is the only discrepancy emerged from the comparison between the two mechanical characterizations, so further investigations are required. Given the obtained findings, the following conclusions can be drawn. Results obtained from rheological studies show that the bio-oil gives perfectly comparable results with the reference bitumen in both aging conditions. On the contrary, lignin involves chemical and rheological changes that lead to the assumption that lignin partially acts as a filler and part as a binder. From the mechanical characterization of asphalt mixtures, no significant differences emerged between the bio-based and the reference ones. Overall, fatigue life seems to be slightly penalized, while a slightly higher resistance to cracking response is proved. Moreover, lower thermal and aging susceptibility is found for the lignin-based binder and asphalt mixture compared to the reference bituminous material. Results deriving from VCD approach confirm what found with the conventional mechanical characterization, highlighting the possibility of its application even on bio-based materials. The only discrepancy was found on fatigue resistance of aged mixtures, which required further investigations. Overall, the promising results encourage the use of such biobinders in asphalt pavements, meeting the sustainability and circular economy principles. Here some research production, and thank you for your attention.